Here we are with a little bit of homework help for Unit 5, Lesson 16, Finding Cone Dimensions. As you recall, we have a lesson that talks about how the formula for a cone has been derived and how that formula for the volume of the cone specifically relates directly to the volume of a cylinder. Remember that a cylinder has a volume. The volume of a cylinder is equal to pi times the radius squared times its height. And the volume of a cone is really very similar to that. The volume is equal to the area of the base, both of them having the area of a circle for the base. Both of them we have to multiply by the height because we need that three-dimensional piece, but what we learned in the lesson is that the cone is 1/3 the volume of a cylinder that has the same radius and the same height. So when we look at this, we see the volume of this cylinder is 175 times pi cubic units. What is the volume of a cone that has the same base area and the same height? Well, if we have the same base area and the same height, we're ultimately looking at a cone that's going to fit right here on the inside, which means that the base area would be equivalent, the height would be equivalent, and so the volume comparative to this cylinder should be just 1/3 that of the cylinder. So if I think about that piece, I take 1/3 of the volume of the cylinder, 175 times pi. I should be able to answer this question. Now, when we answer this and you go ahead and put this into the box, you need to be very thoughtful about what you do. You can answer in terms of pi, which means it would be absolutely precise, or you can approximate to the nearest whole number. Now, if you're not careful, if you don't multiply the values correctly, and if you don't round correctly, you're not going to get the right answer. So be really careful if you do choose to go to a decimal. You can always leave it in exact terms of pi, meaning that whatever you put in there, you put in your number. If it came out to 32, and then rather than putting the symbol for pi, we need to write 32 pi. Okay, so go ahead and give that a shot, see what you can come up with. The next question talks about a cone that has a volume of 12 times pi cubic inches. We are given the height of 4 inches, and the question is, what is the radius? So we may consider looking at a circle. We start with a value like this, and then what we would want to think about with this is how do I draw the part that's somewhat hidden, and I can think about it like this. Assuming that I can really draw a good cone. I'm not super impressed with that one. So what we're after with this is just the understanding of how to set this up. We need to first off remember what the volume for a cone is. The volume is equal to 1/3 times pi times the radius squared times the height. And we can look at what do we actually know about the situation. I know the volume is 12 times pi. I know that the height is 4, and I know that I have to figure out the radius. So as I look into this, I have 1/3 times pi, which could easily be divided out. I also have the radius squared. The radius squared is really the only thing that's going to stay there. So what I need to think about is how can I take 1/3 times 4, which would end up being 4/3 times pi times the radius squared is equal to 12 times pi. And so our final, not our final step, but almost our final step would be to divide out 4/3 times pi, divide that 4/3 times pi. And now you may recall we've talked about the piece where when we divide by a fraction, we're also multiplying by the reciprocal. So we're going to do two things here. First thing, pi divided by pi is 1. So pi is gone because of this. Because of the identity property of multiplication. Two numbers divided by themselves equals 1. 12 divided by 4/3 times 1 is still 12 divided by 4/3. We end up with 12 times the reciprocal of 4/3, which would be 3/4 is equal to the radius squared. If I make 12 into a fraction, it may make it a little bit easier for us. And we get 12 times 3 is 36 divided by 4. That would be a squared number, which means that we have 9 is equal to r squared. Just because I'm such a nice guy, I'm going to remind you how to do this one. It's a special kind of division called the square root to get r by itself, and the square root of 9 is 3, meaning that the radius would be 3. No centimeters cubed, nothing else on there to be able to add to that value. It wouldn't even make sense to put centimeters cubed because the radius is simply just a linear measurement. Okay, you're going to do this again for this next one, for part A. And then, but this time what you know is the radius, you don't know the height. So you're going to be concluding what the height is in there. For part B, we have a cone that has a radius is 2. What is the height? And I failed to mention something. This cone is going to be used all the way through. You have a cone that has a volume. This volume is equal to 3 times pi. So what you'll be doing for part B is you'll be using that 3 times pi is equal to 1/3 of pi times the radius, which we know in this case is 2 to the second power, times the height, solving for h. The next problem, you'll use that 3 pi again, because this cone we're actually recognizing is not going to change. We'll have 3 times pi is equal to 1/3 of pi times, what information did they give us? They give us a radius of 5. So we would have 5 for r. And then we're solving again for h. Remember, simplify this part and then divide the 3 times pi by that part, and you should be able to find the height. Make sure that you're answering in a way that's appropriate to what's been given. If the cone's radius is 1/2, follow the same steps. Substitute the known value for the volume. Insert the numbers that we know. Substitute the numbers that are given to us. So the radius is 1/2 squared. And then we need to find h again. And then part E is one that's just a little bit trickier because they actually just give us r. So if we think about this, again, substitute what we know. 3 times pi is equal to 1/3 of pi times the radius squared times the height. So r actually doesn't change. If the cone's radius is r, what is the height? I'm still looking for this opportunity to get r all by itself. And so when I work through this, what I'm looking for the opportunity to get the height, h, all by itself. And so that height, what I'm looking to do is divide out this portion of it, the 1/3 times pi times r squared. When I work with this, what I'll want to do is divide the same pieces of this, 1/3 times pi times r squared. And then what I want to do is I want to actually, by dividing by 1/3, I want to multiply by the reciprocal, which is 3. So 3 divided by 1/3 is 9. Pi divided by pi is 1. And then we're dividing by r squared. So r squared would be what's left over. This over here is all by itself equal to 1. That's a big 1 because I'm dividing the same thing by itself, but you'll notice that I still have h over here all by itself. And this is what we should get with the height. Remember that when we put this in, 9 should be written as 9. We're going to use a slash because this is a fraction. And then we're going to write r, and we need to write a caret, just like it says right here in the text of what to do with your directions. This is done by pressing shift and 6 at the same time. And then finally, the last part of that, we would put a 2, and that would be how we'd represent the value for that situation. For this problem right here, this is the last problem. It says that 3 people are playing near the water. Person A stands on the dock. Person B starts at the top of a pole and zip lines into the water. Person C climbs out of the water and up the zip line pole. So we have to consider a few things. We're supposed to match these situations based on just the graphs that we're given. So let's use some knowledge to think about this. If the person is just standing on the dock, would their elevation at all above the water, this is the water level right here, would their elevation ever be changing if they're just standing still? Let's assume that what's happening right here, it says match the people to the graphs where the horizontal axis represents time in seconds, and the vertical axis represents height in feet above the water level. So there's our water level, there's our height. Looking at time, we know the person A is just standing still. Shouldn't say a whole lot of, or it should say a lot about their slope. Person B is on a zip line. I want you to think about that. On a zip lines are always going to go downhill and they will go pretty rapid. So we should be able to match that one with the appropriate slope. And then finally, person C, they're climbing up out of the water. That means that they were in the water. They have to be below the water line. I don't know how to make this any more obvious, but make sure you select the right people, the right selections here on parts A, B, and C. And then you're all done with your homework. Thanks for checking in. Better double check. Yep, that's really all it is. Thanks for doing your work. Let me know how I can help. Have a great day.